Hello again, and welcome to round 2 of the attempt to implement explicit turn ordering, and this is going to involve a lot of ECS refactoring. So where we left off is this guy here. A few days ago, I implemented explicit turn ordering, or at least I tried to, and as I note here in the commit message, the implementation is quite cumbersome and is difficult to reason about. We have some quirks. The movement mostly works. If I press attack, we see this guy attack me 2 or 3 times. And it took me a moment to figure out what was going on. I did it off camera, but let's build a little example here. Let's make an array and an array view. So we'll have an array, which will be, the type will just be 5 ints. And then we will say for A, we'll just populate A with 0 through 4. And then we will take a view here. Just make sure this works really quick. Okay, so we are now printing the contents of A through the view V. Now if I iterate over V and mutate it, let's see what happens. So a quick explanation of what I'm doing. I'm iterating over the backing storage A via the view over it, V, and before I do some logic, I will print the contents of the backing storage according to whatever view I have over it, V, at this time. And if I happen to hit the element of value 2, then I will remove that element using the special keyword here, remove. And then I'll just print the contents of the view after that operation. So if we look at the output here, the reason that we only iterate 4 times is because the third iteration through, we do mutate the backing storage. And what we've done is we've deleted the element with value 2. We've done that by taking the element in the last position, which is 4, putting it into the element in position 2, and decrementing the count by 1. When we step to the last element here, this will be the last iteration through the collection, because we now only have 4 elements, not 5, and that's how that remove keyword works. But let's see what happens if we don't use remove, but instead we do something like this. So now we are chopping off the first element, essentially v.data plus equals 1 and v.count minus equals 1 here. Chopping off the first element essentially has this effect on the second, or rather third, counting from 0 iteration through, which is first we start with a full collection, and then what we do is we bump the data pointer, so we erase this guy, logically erase him, and the beginning of the collection is now 1, as evidenced by this, and then we decrement count, so we no longer have 5 elements, we only have 4, and so a similar behavior from last time, we only loop through the collection for times. I'm going to start disentangling the passes through the ECS, and we're still going to have these weird latent defects in here, but after I disentangle the passes through the ECS, then we can switch the backing data structure for turns, and we can try and make this logic more sane. So the first thing I want to do, I think, is disentangle the timer updates and the state updates here. Also, this procedure is just massive, so I'm going to be breaking this stuff out into multiple procedures. So if I come down here, we can call one of these guys update timers, and we'll have update states. So we will take entities, which is a pointer to entities, and components, which is maybe not a pointer. We'll just take it however it's passed to the update states here, which is going to be, yeah, so we take entities by pointer and components just by components, a non-pointer to components, update timers and the entities and components right there. Get rid of all this logic. We've already done that. Time since last, oh yeah, we do need to pass in delta time to the update timer guy. So we'll pass in a delta time, which is game state time since last frame in seconds. We now call this just delta time. Update states, we'll paste in there. I guess we're going to take in another entities and components. Animation action is playing. Okay, I do want to return this back to the caller. This was something that we were not propagating, but we were setting kind of in one nested scope and then using in other nested scopes in the original implementation. This is kind of one of the things I want to disentangle. So we will return a bool from here, and I guess we just call that action animation is playing. I think we actually share this logic as well. We're attacking, and yeah, so this logic is exactly duplicated, so we can just consolidate all of this. Case player will be, what is it? Pound through, I think it is. So we can get rid of all of this guy, I think. What we call that now? Oh, okay, I'm duplicating the name, so I guess we'll just call this guy update. So now to disentangle this loop here, I think. Another thing I'm thinking, by the way, is to change the entire concept of what a turn is, because initially, before I started kind of expanding the idea of the game, the design of the game here, the turns had actual like wall clock time based cooldowns, and that doesn't really make sense in a game where you want to stall all action until until the player performs some sort of movement. Okay, so yeah, we have another tricky thing here, which is like, if you look at the implementation of this current loop, this entire loop constitutes one turn. And we know that the player comes first just because of the way I store entities in the ECS. And a player will take a turn when the player either attacks or moves. But if it is the player's turn and the player does nothing, this is considered stalling. And if we stall, then all other entities have to wait because, as I mentioned, the other entity movement or action is gated on player movement. And so if we break apart movement and attack in here, we can no longer loop through all entities once for attack and then loop through all entities afterward again for movement, because it might be the case that it's the player's turn and the player neither attacks nor moves, and we need to know that before we give other entities a chance to attack. So I think now we still iterate through all entities, and then we have an attack procedure and a move procedure, and these operate on individual entities, not collections of entities. I think here we need to have like an attack call and a move call. We need to know if someone attacked, and we need to know if the player stalled. And if the player stalled, then we just, we break. I think we break. So the logic here is we know that the player is going to get processed first when we go, or I shouldn't say we know that. If the player gets processed first and the player chooses to attack, then actually we need to do this. If someone attacked, great. So this is already, I don't know, a little strange. It's a little strange, but let's assume that the player is first in the turn order. So if the player gets a chance to attack, if the player decides to attack, that counts as a turn, and then we will move into kind of animation stalling or entity stalling based on attack animation or something. So we need to break out of this loop and turns. Or actually, we need to make sure that either in attack or in this body before we break that we decrement, or rather we pop the player off the turns queue. So we need to do that, and then we get out of here. If it is the player's turn and the player doesn't attack, then the player has a chance to move. And let's see, if the player actually moves, then we just continue through the loop here and everyone else gets a turn because we don't trigger an attack animation on a move. So the other entities get to play. If it is the player's turn, but the player made it to move and the player doesn't move, that's considered stalling. And so if the player stalls, then we just break. That keeps the player in the collection of turns. And then on the next frame, we come back through here and the player is first, and then we rerun the same logic. If the player is not the first in the collection, then either a ghost or an enemy attacks and then breaks out of the loop, so that way we can start playing the attack animation on the next frame, or I guess this frame even. Otherwise, enemies, I'm going to treat enemy movement as always succeeding, whether or not they're actually able to move. This way, a stuck enemy doesn't sit in the turn queue forever and block the block the progression of the game, essentially. So I think this logic right here is mostly fine. We just need to now figure out what goes in the implementation of the attack procedure, and also when we actually when we pop an entity off the turn queue. We have to figure that out. So the turns thing, I really want to get rid of this. Oh, we are going to get rid of it because attack is going to work on a single entity. So if we actually go up to where we call attack here, we will be passing in, I guess, an entity index or something like this. But we can get rid of the loop. That's good news. Let's see. So we make an entity view here, which I think is fine. We'll take the it index, not it index, the entity index here. That will be a property or a parameter. It's going to be an S64. We also do need the entities and components. Yeah, and attack is going to have to signal something, so we will return a bool. I forgot what we just said someone attack. Someone attack. That's what we called it. The case for the player and for the ghost are different because the player uses input, so we'll need input as well. This else break thing, we'll leave that in there for now. But I do want to get rid of that. Well, the break has no meaning here because we're not in a loop, so I'll just get rid of that, I guess. What did this mean, though? This was the nasty control flow from that consolidated loop where if it was the player's turn, but the player didn't do anything, then we would stall. And we needed to signal stalling by just preventing the other entities from updating. So we can get rid of that break now. Action started is now called someone attack. We do need to track that here. So we'll start that we're in the idle state. Input signals movement, we don't need that anymore. We have this continue, which this is not going to work either. And this is if we are in an action cooldown. This is going to be a pain to deal with. We can't continue. Do we return for the time being? What kind of preserves? I guess a return would preserve functional parity. Continue, that would have originally left us in the turn queue, but skipped our turn. I guess if we break, that will do the same thing, but I definitely need to come back and fix this. Not break, sorry, if we return. And we no longer have turns here, and so this is where stuff gets a little more complicated. We need to signal back to the outer loop that we have taken a turn. Well, we know that this line just needs to go away because we don't have turns in the scope anyway, so we'll get rid of that. Yeah, so this is going to be called someone attack, true. I think we need to do this conditionally here. So if someone attacked, and we could do this in the outer scope as well. We have to go back and reason about the outer loop here. So if we just remove this for now and just look at what the outer loop looks like. This is what the outer loop looks like now. So we do an attack, and if somebody did attack, then we are going to modify the backing turn view. And we do that because we are going to break out of this loop, and we need to preserve the order of turns in our game state. So that way, when we come through this entire procedure on the next frame, we start processing the right character or the right entity. We don't start from the very beginning again. So now let's look at move. Okay, so I need to take input as well. So we're going to take the entity index, which is S64. Pointer to entities. Components will be components. Input is going to be the game.input. We know we need input. I do see we're taking in game state here as well. Game state map, because we're checking if we can move to a certain position, and we need map information for that. BS is going to be game state. This whole break thing. Oh yeah, all these. Okay, we have a lot of these breaks. I leave breaks up in the attack implementation. I do. I have some breaks here, so we'll get rid of this. If input selecting facing direction, we don't need to break here. Instead, we say player stalled is true. We consider selecting the facing direction as stalling because the player is going to perform pseudo movement, just facing direction movement. But the player is not technically going to take a turn. They're just going to change where they're looking. So that will be considered stalling. Otherwise, we know that we have input that signals movement, and we're not selecting the facing direction, so we are going to attempt to move. I think down here, we do update the backing turn collection, but we only need to do that if somebody actually moves. So I probably need to introduce another Boolean, maybe just local to this function. Okay, otherwise, we consider this player stalled true. So the player attempted movement, but wasn't able to move, and so we're just not going to count that as a turn. This else break thing, let's see. This is going to be the case if we come into the movement procedure, but we don't attempt to do anything. This is also stalling. So player stalled is true. So as I mentioned before, I think we're always going to say someone moved is true here, because even if the ghost gets stuck, if the ghost is perpetually stuck and we don't count that as movement, then they're going to block the turn queue forever, essentially. So we have to say someone moved is true. Okay, someone moved is true. Then we do the similar thing down here. If someone moved, then we need to, I'll probably lift that out into the outer scope. But then I would need to return two bools. I'll need to return if somebody moved, and I'll need to return if the player stalled. So we now return someone moved and player stalled. Okay, so this is currently what this looks like now. It couldn't be simpler. Nice and complicated. Pathfinding arena we need to make in the outer scope, and then we initialize it and set it all here. The allocator we could probably make in the scope of move. Okay, not enough return values, wanted 1, but we got 0. So here, we'll just return false. So ideally, by the way, ideally what I would do instead of returning false here is I would rip this entire line out and I would introduce yet another pass through the ECS before taking a turn. So before attack and move, I would take another pass through the ECS, and I would just remove anybody in the turn queue that still has some action timer remaining because they're otherwise going to get skipped. I am not crashing, which is great. All behavior appears to be preserved, including the wonkiness. So I attack once, they attack, 3 times. At the expense of actually introducing more code, because we have duplicated the switching multiple times across multiple scopes here, we made the state update more fine-grained. So now that we have this, I'm hoping this will help us debug more. Because timers are involved, it's difficult for me to debug this in GDB, because it's wall clock time, not number of frames or anything like that. When the player performs an action, their cooldown is half a second. When an enemy performs an action, their cooldown is animation attack cooldown, which is 0.15 seconds. So this is probably why the enemies get to attack 3 times. Let's just set this to, not to H, but rather to player action cooldown seconds, and see what effect that has. The movement is still fine, so I attack once, he attacks twice, okay. So it made a difference, but it didn't fix the problem. Probably pays to have these cooldowns be the same thing for now. Okay, the fact that these cooldowns are different means that we have different cooldowns depending on action type. The run cooldown, I think we need to leave the run cooldown as is, because this is kind of what makes the game currently playable from the sense of not zipping across the screen at 60 FPS. This is the run cooldown. Maybe I just set the action cooldown to the run cooldown at this time and see if that fixes that issue for now. Let's actually give it a check. So the action cooldown, I guess I'll just set to the player run cooldown seconds for now. One attack, one attack. Okay, so one attack. Okay, so that fixed the issue there. That's cool. I think I'm ultimately going to solve this by getting rid of these cooldowns with the exception of one, which is kind of like a turn cooldown. We have a view, which is a copy of another view. This entity's turn is the original view, right, that we copy. And so I think if I replace turns with entity's turn, we're gonna start to see some really wonky behavior. Yeah, so as you can see, the movement's all messed up here. The reason this is happening is because we are modifying the view that we are also iterating over. Perhaps easiest to explain with some print statements. Then we will print the iteration index %, and then we'll print another entities.turn %, its index, and entities turn. And we're stalling right now, which is why it's 0, 1, 2, 3. But then if I just press down to move, I'll press down and kill the game real quick. So down and kill the game. In this moment, I have pressed down. And after I press down, I pop my guy off the front. And now the very first entity in the turn queue is 1. However, the it index that we're using is 1 as well. So we don't look at the 0th element. We look at the element at index 1, which is going to be entity 2, and then he takes a turn and whatnot, and then again we pop off the top of the collection here, and so we don't see it here, we see it in the next pass, the next frame. What we're left with from the previous iteration is a collection of just 2 turns, and again we take the 0th element, which is going to be entity 2 on the next frame, and then we increment the it index. Curiously, view actually did not get the first element popped off. So yeah, so here's the real wonkiness. It's really difficult to understand from this hieroglyphic here, but remember that we have action cooldowns, right? So on this last pass through the frame here, we have this guy, which is index 1, which is going to be entity ID 2. And then on the very next frame, so remember entity with ID 2 moved. And so there is a cooldown applied. There's an action cooldown in effect for entity with ID 2. On the very next frame, because of the wonky, broken way that I've updated the backing view while iterating through it, we attempt to allow entity with index 2 to take a turn again. But this entity has a cooldown applied. And currently, what that means, if you have a cooldown applied, if we look at, let's say, attack here, right, we're doing this thing. If I have an action timer cooldown applied, I just return false. So this is not counted as an attack. And I do the same thing for movement as well. So that's why this guy actually stays in the turn queue, but we just skip his index and we go to the next guy and say, okay, 3, you get to take a turn. And because 3 takes a turn, we, again, with the broken update logic I have, we remove the first element. So on the very next frame, we have the turn queue has a single element left, which is the last element. It's actually the guy that got to previously go, but now, because the index was kind of off by 1, now he remains in the turn queue because we deleted the first guy instead of the second guy. And now this guy has a cooldown, but he's in the turn queue. So we see him kind of stall the game for a little bit while we're waiting for his cooldown to expire. Once his cooldown actually expires, then he is index 0. He's able to move. He exhausts the turn queue, and then we repopulate the turn queue. And I'm not holding any input or anything like that. And so we enter the player stalling mode. So that's a long explanation of a complicated situation that is a consequence of the way I chose to do the tracking of the turn ordering. We can fix this in multiple ways. So the first idea is to simply not use a view for turns, but use an actual proper queue. I have a queue data structure that I've implemented. We could use a proper queue. How to iterate over that queue and make sure we have the indices correct, that will be another adventure. The second thing that we could do is we could actually prune the turn queue based on cooldown before we start doing this loop. And right here we are going to prune the turn queue for entities that have some cooldown, that have live action cooldowns. This logic is now moot. This logic should never trigger. In fact, we will assert false. Attack, this is an 801. Are we hitting a timeout assert? We are. Look at that. Not a timeout, a cooldown. Oh, okay. Right. So I'm falling for the exact same issue that I was describing earlier, right? When we're pruning, we're looping through all of the entities in the turn queue. But let's say entity 0 does not have, an active action cooldown, but entity 1 does. If entity 1 does, we are popping entity 0 off the turn queue because we're bumping data. We actually have to do a remove. We just need to shift everybody down. We don't want to reorder the turn queue. For it index to turns count -1. Is it turns count -2 actually? Maybe -2. Entity's turn at it is entity's turn bit +1. We still need to do this. Entities turn.count minus equal 1. Okay, nope. So attempted index is 3, but the highest valid index is 2. Good news is we can see something going on here, right? This is useful. When I attempt to move, I do move, and then the next guy, we have 1, 2, 3, then this is, at index 1. Uh-oh, what's happening here? Yeah, so okay, the bounds are wrong here, because I am modifying stuff at entities.turn. This actually probably needs to be entities.turn.count. Okay, so I'm still not pruning correctly, because we are still tripping this action timer situation here. We're running into the same issue that we were hitting previously, where we're like mutating a collection as we're iterating over it. We're jumping over elements, we're leaving elements in the turn queue that have a live cooldown. I guess manually control the loop iterator. Turns index, gonna be 0. Yeah, I think that's what we need to do here. So we make an entity view of the turns index and we check the property, the timer property. If it is greater than 0, we need to start doing some logic here, which is going to be now turns index to entities turn count minus 2, and then entities turn at it. And then I think we say otherwise turns index is 1. And then we need to say if turns index greater than or equal to entities turn count, then break. The more I work into this, the crazier it seems. But the good news is, it actually seems to have worked. Okay, I do have some issue there where I'm like attacking crazy fast. Okay, so the whole point of this exercise was to get something in hand that was refactored and structurally different than what I started with the turn order management. So that way I could actually have some data and some experience, something tangible to reason about, to figure out whether or not this is a good approach, whether or not, I really want the ECS and this kind of design for my turn-based game or not. Clearly there is a way to make it work. I feel this is not elegant at all, and so I want to do some more thinking about it. Maybe also introduce a queue. So instead of using a view, use a queue, see if that cleans up some of the crazy logic that we have. Thanks so much for tuning in today, and cheers. You guys have a nice rest of the day. Peace.